The majority of this video is speeded up by at least twice the normal speed. Hello, further to my previous video showing how I created a flare on the end of a piece of copper tube. The flare joint is commonly used to connect a pipe set to the outdoor unit of a mini split system. In this video I'm going to show how I braze or solder fittings on the pipe set. Brazed or soldered fittings can be used anywhere on the pipe set, but when the refrigerant is R290, brazed or soldered fittings must be used if joining the pipe set inside a building. So before I start any soldering or brazing, I make sure that I'm in full control of my surroundings, i.e. I've made sure there's nothing combustible nearby, and if there is something combustible I'll protect it with a burn barrier or something not combustible, such as you can see here I've got some tile backer board which does the job perfectly well, and it doesn't transfer the heat to the surface it's protecting. I also have a wet cloth on hand, and I also have a fire extinguisher just in case. In this instance I'm using a swaging tool to form a coupling on the end of the pipe. I would prefer to use a manufactured fitting, but in this instance I haven't got any. As you can see here, fittings of the correct size are available, and the wall thickness on these fittings is much greater than the wall thickness on general plumbing fittings. Here I have some 1/4 inch pipework in some insulation. This is typically what's supplied with a mini split system. After moving the insulation back far enough so it won't be affected by the heat, with the mini cutters I cut off a section of this pipe so that I can demonstrate how I join two pieces of pipe together using a soldered joint and a brazed joint. Once the pipe's cut, it's burred over a little bit on the inside, so I use the pin nose pliers to just ream it out a little bit. You can also use a knife blade, but this might cause a little bit of swarf to go inside the pipe, so I do prefer to use the pin nose pliers method. Now I've got to form the coupling on the end of the pipe. Now what I use for that is a pipe swaging tool, and that basically goes inside a drill. Here you can see I'm having to grip the pipe with a pair of mole grips. I'm having to do this because I've got a problem with my hand and it's difficult to grip a pipe with this very small diameter. Basically I just put the swaging tool into the end of the pipe and start pushing it, and as you can see it's starting to form a socket at the end of the pipe. During this process the pipe gets quite hot. As you can see, although this is relatively soft copper, I have to really push the tool to form the joint. Normally I would grip and support the pipe closer to the end where the joint is being formed, but as I'm filming this I've held it back a little bit further so that my hand's not obscuring the camera angle. So once I'm happy the joint's formed and I've cooled the pipe down, the object of the exercise now is to get the pipe as clean as possible. Now to do this you can use steel wool, but that's got a tendency to leave debris lying around, so I like to use this abrasive cloth stuff that you get from the plumber's merchant. So I'm cleaning the fitting inside and out quite thoroughly. I know for larger pipe sizes such as 15 and 22mm that there are tubular type wire brushes available, but I'm not sure if there are any available for these smaller pipe sizes. So what I do, I roll up some of this cloth stuff and use that to clean the inside of the fitting. When I'm happy that both male and female parts of the joint are clean, I assemble the joint to make sure they go together properly. Here you can see I've put a mark on the pipe to use as a reference. Once I'm happy that the two parts of the joint have gone together nicely, I start applying the heat. For this joint I'm using a brazing rod with the flux infused into the rod itself. So I'm applying the heat to the pipe because it's the temperature of the pipe that's going to melt the filling rod. The hottest part of the blowtorch flame is right at the tip of the blue inner cone of the flame. As you can see I keep touching the pipe to test when the pipe is going to be hot enough to melt the rod. Once the rod starts melting, I maintain the heat on the joint to ensure that it flows all the way round. It's important to keep the heat focused on the joint, as the brazing rod has a very high melting point, and as soon as the heat is taken away from the joint, it will stop flowing. Once the newly brazed joint has cooled down naturally for a second or two, I then cool it further with a wet cloth and get as much of the oxidisation off the pipe as I possibly can. So there it is, in my opinion, a perfectly brazed joint. Although I'm very confident that it is a perfectly brazed joint, I will test it before I release refrigerant into the pipe set. Now I'm going to repeat this procedure, but this time I'm going to solder the joint. Thank you if you have already subscribed, and if you haven't subscribed, I wonder if you would consider doing so. It is free and it helps give incentive to create more content. Thank you. As you can see here, it's easier to form the joint on the end of the pipe because the pipe has become annealed, softened, due to the previous heating up process. Although the melting temperature of this particular solder is quite a bit lower than the melting temperature of the brazing rod, the solder that I'm going to use is specifically designed for air conditioning. It has a high silver content, and it's not like the solder that you use for general plumbing. It's much harder. And although the melting temperature is much higher than general plumbing solder, the melting temperature of this solder is lower than the melting temperature of the brazing rod. The flux for this soldering job has to be applied separately, and this is a specific high temperature flux for soldering. Normal plumbing flux won't be any good because the temperatures are too high. As you can see here, the solder flows at a much lower temperature than the brazing rod. So there it is. Once it's cooled and cleaned, you can see the difference between the two joints. I personally think that both methods of joining are equal. They both do the same job.